Hello, this video is about SnakeGrid Object, which is a plugin for the FME software. My name is Jonathan Iliff. Myself and my colleague James Turner are going to be telling you about how this software works. I'm going to start off by describing why we need the software, and then I'm going to pass over to James, who will tell you how it operates within FME. The starting point for this is a design file looking like this, a GGN file for MicroStation, something similar to that one. And we want to transform it from one coordinate system to another one. That looks a little bit complicated. Let's take a more simplified one just here. Here we've got a couple of straights joined by a curve of radius of curvature 200 meters, a platform, a certain gap in between these elements, and all of that is in coordinate system A. We want to transform that into another coordinate system. Maybe it's in one of the SnakeGrid coordinate systems, and we want to put it into the Ordnance Survey National Grid, or UTN, or the State Plane Coordinate System, or something like this. When we do it, things are going to be of different size. It's the natural way that it would happen, because the scale factor is different between these two systems. It could typically look with numbers like this. Of course, things haven't really changed their sizes. It's just that our understanding of the coordinates is different between the two systems. And so what was a 200-meter platform in one system has ended up as 8 centimeters longer when we look at it in a different coordinate system. So everything's changed its size, everything has scaled. That gap you'll notice in between the platform and the straight has also scaled itself slightly. The radius of curvature has scaled itself. This is a kind of a correct transformation. We call it a transformation by vertex. But it may not be appropriate for everybody. It may be that you want some of these particular objects to keep their original size, their original dimensions. So we've given you a couple of different options within SnakeGrid Object. One of them is to do it like this. Just take the whole thing and move it to the correct position, but leave it in the same size. We call this a transformation by the centroid of all objects. Everything is the same size as it was before. All the gaps in between the objects, their relative positions are all the same. It's just been moved to the new coordinate position with the correct new coordinate orientation. But you'll notice that things which weren't part of this transformation, just the continuation of those straights, for example, which haven't been transformed in the same way, are now not matching anymore. So it may be that this is an appropriate thing for you to do. It may be that you've got something like a very, very complex diagram that you want to, complex bundle of objects which you want to maintain in their same relative position and so on, that you want to move. And it could be that you accept that this kind of mismatch is going to be an acceptable amount. So what we'll do is we'll give you the ability to do this, but also with SnakeGrid Object, it'll give you the ability to analyze, to tell you what the mismatch is if you do choose to do a transformation of this sort. Another kind of option that we give people, with users with this system, is to take that coordinate system and do a transformation of each individual object. So not the centroid of all the objects moving together, but each of these individual objects moving. So the platform has still remained a 200-meter long platform. That straight is still a 200-meter long straight. It's still a 200-meter long radius of curvature, but the relative positions between things have actually altered slightly. You see that that gap is no longer 1 meter. It's changed slightly. So each object within that diagram has been moved to the correct position, and but it's maintained its original correct size that it was in the original diagram. We call this a transformation by each object centroid. And again, you'll notice that there's a slight mismatch between what has been transformed and things which are not transformed, the continuation of these, which we put in symbolically just by here. And again, if that is a sub-millimeter mismatch, then this may be a more convenient option than doing the whole thing by the vertex. So that gives you a rough idea of why the different options are introduced within SnakeGrid Object. What I'll do is I'll hand over to James Turner to explain how it is that we do that with the actual SnakeGrid Object software in FME.
Thank you, Jonathan. We now move on to the demonstration of the SnakeGrid Object plugin for FME. I will start a new workspace and add a reader. The dataset is a shapefile, and the shapefile is an outline of Reading Station. I'll route this into the FME data inspector. So we can take an initial look at it. Click play. And there we have it. This outline of Reading Station is composed of 3 separate but continuous polygons, and it is currently in the SnakeGrid coordinate system. What we'll do now is use SnakeGrid Object to reproject from SnakeGrid into British National Grid. And to do this, I will add the SnakeGrid Object transformer. And adjust the settings. As John described, there are 3 different reprojection modes. The first by vertex, then by centroid of all objects, and then by individual object centroid. So the first one we'll try is reproject by vertex. This is the same method as used by the SnakeGrid projector transformer. The source coordinate system in this case is SnakeGrid. Destination coordinate system is OSGB 36. This is the same as British National Grid, and it uses the OSTN02 transformation. We must specify a SnakeGrid parameter file. Every SnakeGrid is defined by a custom parameter file. In this case it is the Crossrail 09 SnakeGrid. Okay. SnakeGrid object has 2 outputs. The first is an HTML report. This can be written using a writer, a text writer, into an HTML file. And I will call that file report.html. Okay. I will route the HTML to the text writer. The output can go into another transformer or to a writer, but the output is the reprojected features themselves. In this case, I will put them straight into the inspector so we can look at them immediately. Click play on the workspace. And there we have it. The outline of Reading Station has been reprojected into British National Grid. And we can have a look at the report. The report contains information on the name of the parameter file, what mode was used to reproject, the source coordinate system, the destination coordinate system, and following this is a table with an entry for each particular feature with a unique identifier and the type of object. In this case they are all polygons or areas. And a particular interest in this table, it gives the original perimeter length of each polygon. And it also gives the reprojected perimeter length of each polygon. And the same for area. As you can see, because we reprojected by vertex, the perimeter length and area of each object have slightly changed. This is expected, and it means the objects are in the correct location for this projection. Therefore, no distortion has been introduced. So I'll close that. Now open FME again. And I'll go into the option number 2. Reprojection by centroid of all objects. In this case, the centroid of all the objects will be determined and the reprojection will be done with respect to that. Consequently, the size and shape of all the objects and their positions relative to each other will stay the same. So I'll run that translation. And there we have it. Within the data inspector, it looks virtually identical to the results from the previous reprojection. However, when we check the report, we see some subtle differences. Projection mode is now Centroid all, and the original and reprojected lengths of each object are identical. They have not been changed. The same with the original and reprojected areas. However, we have now introduced a distortion. For this particular polygon, it's of the order of 23 millimeters at the outer edges. Similarly, the centroid of each object also feature errors, in this case up to 24 millimeters. Moving on, we'll go on to the third option. Third option is to reproject by object centroid. That's individual centroid. So in this particular case, the size and shape of each object will remain the same. However, there is no guarantee that their positions relative to each other will be consistent. For example, it's a subtle difference. If I zoom in, you can see that the Reading Station polygons now overlap and do not join correctly. I'll close this window and open the report. In this case, projection mode is centroid. The size and shape of each object, once again, before and after the projection, are identical. However, the distortion is up to 23 millimeters, and we also have centroid position error as well. And the relative positions, as you've seen from the data inspector, are not consistent. So there we have it. Those are the three different modes of reprojection and the output analysis report. The use of each one is largely driven by your needs and desires. However, you can also contact UCL for further advice as necessary. Thank you very much for listening, and wish you the best.